let's take a look at a situation. There was an article written in the Business Insider in 2014 that talks about a connection between eating more chocolate and winning the Nobel Prize. Here's a scatter plot that was created with some country data, and we can see that our correlation coefficient is 0.791. We're going to replicate somewhat this information, but our data is slightly different than what's provided here, because this is just a graph. It's hard to read it. So our data is here in the table. We want to determine if there's a correlation between chocolate consumption and Nobel laureates. We have 23 pairs of data. We'll use a significance level of 0.05 and create our hypothesis test. So here we go. First up, null hypothesis, rho equals 0. Alternative hypothesis, rho is not equal to 0. And since we've already seen some semblance of a scatter plot, we have a suspicion that it might be linearly correlated. We'll make that alternative hypothesis our claim. We have our data here. I'm going to use our function in Excel, correl, and we'll click on array 1, which will be chocolate, and then array 2, which will be our Nobel laureates. And we hit enter and we get 0.801. Our alpha is 0.05, so we need to find our critical value. And our critical value is t.inv. We'll put in 0.05 divided by 2 because a linear correlation is always a two-tailed test. We have 23 pairs of data, so our degrees of freedom n minus 2 will give us 21. So let's go back to Excel and calculate that. Critical value, T inverse, 0.05 divided by 2, and 21 degrees of freedom. And we get negative 2.0796. If we round to 3 decimal places, that will be negative 2.080. Since it's a two-tailed test, even though I got the negative, I'm going to go ahead and include the positive because of that symmetry with t. Before I calculate the test statistic, I'm going to go ahead and draw my graph, and we'll put 2.080 and negative 2.080 in there with our rejection regions in the tails. And now we need to calculate our test statistic. Our test value. Those words are used interchangeably. Test statistic, test value. Our formula is r times the square root n minus 2 divided by 1 minus r squared. And we can either put that into Excel or we can use our calculator. I'm going to put it into Excel. So our test statistic, r times square root n minus 2 is 21 divided by, I need a parentheses because I'm dividing by more than one thing, 1 minus r squared, and we get 6.123. Putting 6.123 onto our graph, 6 is very much to the right of 2.080. So we'll put it on the right, and this means we are rejecting the null hypothesis. So there is evidence to support a linear correlation between chocolate consumption and Nobel laureates. But this is kind of silly. It's likely just a coincidence that chocolate and Nobel laureates go together. We really need to use common sense when we're interpreting our results, and it seems a little silly that we would think there would be this relationship between two very unrelated things. This does tie back all the way to when we talked about misuses of statistics back in the first chapter, where we had silly things like Nicolas Cage movies and swimming disasters and other very strangely related things. Sometimes there's just a relationship in the data that exists just because. Coincidence. There's no real rhyme or reason behind them. But it makes for a good practice to exercise how to do a correlation test.